With compound inequalities, we have two options. They're either and or problems. And the problem will tell us if it's an and or problem. With and problems, what we're looking for once we graph the two inequalities is the intersection between the two graphs, if there's any intersection or not. And with OR problems, you're looking at the union of the two graphs. So anything that is shaded on that number line would be the compound solution. Let me show you exactly what we mean. Before we get good and started, before I graph, my trick whenever I write the answer in interval notation, I ask myself, where is their overlap? And this is for and. For or, I say, where is there a graph on the number line? And basically, if we're saying where is there a graph on the number line, I get rid of blank space on the number line. So let's look at these. I'm going to start off by graphing the inequalities. Now you can see that the inequalities on the left are the same as the ones on the right. I'm just going to give you two different, so the graphs will look the same. I'm just going to give you the different interval notations for the and or problems. So the first one is x is less than 5 and x is less than, this is going to be with a parentheses, x is less than -2. And the inequality on the left is the same as the one on the right, so the graphs are the same. Do notice how I draw the graph of one inequality on the top of the number line and the graph of the next inequality is on the bottom side of that number line. I just do that because I get a really good visual when I do this. Now let's do x is less than 5 and x is greater than -2. So x is less than 5. I'm going to put that one on the top. We're using a parenthesis sign. And x is greater than -2. I put this graph on the bottom. Now notice with the one on the right, I put x is greater than -2. I put that on top of the number line, and I put x is less than 5 on the bottom of the number line. It doesn't matter which inequality I put on the top or the bottom. I really don't even have to put them both on opposite sides. I could put both the graphs on the top or both the graphs on the bottom. I just do this for a visual. So again, it doesn't matter which one goes on top or bottom. It will give you the same answer for your solution. So x is greater than 5. And x is greater than -2. And then for my last set of inequalities, I have x is greater than 5 and x is less than -2. So I want to look back at my first example. Remember, and is looking for overlap, and we're going to read these graphs from left to right. So if I start on the left, I have overlap from negative infinity all the way until I get to this -2, And then all of a sudden, my overlap, those two graphs being on top of each other, stops at -2. So since and only cares about overlap, I have that overlap from -infinity to -2 with a parenthesis, because I have a parenthesis right here, and that would be my answer. Now, OR says, where is there a graph on the number line? The number line right here in blue. Where is there a graph on that number line? So we start from left to right, and I have a graph at -infinity, and I keep on having a graph. And there at -2, my overlap ends, but I don't care anything about overlap with OR. So I keep on going to the right, I keep on going, and then at 5, all of a sudden, I stop having a graph. So we could notate this interval by saying it's from -infinity to 5. And we get a parenthesis with the 5 because the graph had that parenthesis. And you can note that on my notes I wrote get rid of the blank space. Well, that's sort of what I did. I said, where is there a graph? And by notating where there was a graph, that blank space is not accounted for. In example 2, we start off looking for that overlap. And I start at -infinity and I don't have overlap, but all of a sudden I get to -2 and these two graphs are on top of each other all the way till we get to 5. And then I don't overlap anymore. So that overlap happens from -2 to 5. And OR says, where is there a graph on that number line? Get rid of the blank space. Well, there's no blank space on this number line. It's all covered with the graph. I do have overlap from 2 to 5 still, but again, I don't care about overlap. I just say, where is there a graph? There's no blank space on that number line. So it would be from -infinity to +infinity. Okay, example 3. We start out, we don't have a graph at all. And then at 2, we start having a graph, but there's no overlap. And at 5, we start getting overlap. And it continues forever after that. So from 5 to infinity would be our overlap. And then for our OR portion, we're looking for where there is a graph on this number line. Get rid of the blank space. Well, I can see that I have blank space right here from -infinity to 2, or excuse me, -2. And so that sort of helps me out because now I can say I clearly have a graph from -2 till infinity. Now, I do have overlap from 5 to infinity, but OR doesn't care about overlap, so we don't have to worry about it. Now, for example 4, I'm looking for my overlap, and it's just not clear to me where it's at. I'll look for it, starting off at -infinity, I don't have it, and then I don't have a graph at all. And then I don't have it starting from 5 to infinity. There's no overlap at all. So this one would be no solution. In fact, if we had to graph the solution of this compound inequality, it would just be a blank graph because there was a blank number line because there was no solution to it. And with number 4, I start off looking for my blank space, and that clearly helps me know where I have a graph at on this number line. I have a graph starting at -infinity, and then it ends at 2. And then I pick back up at 5 and go to infinity, and I have to union those two graphs together with the union symbol.